Hello, good morning.
Good morning, sir.
Good morning. Is it audible?
Morning. Yes, sir, it's audible.
And sharing also.
Yes,
Yes,
sir.
sir.
Shall we start or we have to wait for friends?
Can start,
Basically,
sir.
I posted the mail. You are having some problem, no? Hello?
Yes, sir. Yes, sir.
Regarding videos, no? You can download from the Google also, no problem.
Sir, but access is not given, sir, for those videos.
Access means it is in Google Drive only, no?
Yes, sir, but when we are opening through our student mail, it is not opening. It is asking for access.
Access is asking, no? Okay, I will check
Yes,
up
sir.
after the class.
Okay, sir. Thank you.
And one more thing also, we are giving for the minor examination for introduction. 1 minute. Introduction, SI engines and CI engines and two-stroke engines. It will be object type only, 25 questions and 25 marks. Hello?
Yes.
Is it audible to everyone?
Yes, sir. Yes.
Audible.
Okay, I hope all PPTs has received from SI engines and CI engines and introduction and other parts. Okay. And based on this only, we are going to give 25 objective type questions for the minor. And minor will be conducted on 16th or 17th. It's your choice, time. 16th and 17th, you can plan it accordingly. We'll have an examination. Okay. And by today evening, I may be posting for two-stroke engines and supercharging and turbocharging assignment for problems, 10 problems, 20 problems I will give you with hints. You try for the solutions. If solution is not there, then we'll have one class for that also. So first, I am giving chance to you to solve the problems based on their hints. Okay, is it okay for you?
Yes.
You can plan according to the 16th and 17th, which slot is free. 1 hour is required for us for the different batches. A section and B section, whichever is convenient, you can tell me. I can post the minor examinations and I will conduct the minor examinations in through LMS mode only. Okay.
Okay,
Any
sir.
doubt, any clarifications, you can ask me, no problem. Today I will rectify your problem about the videos and all. I try to rectify it to see. Okay. Shall we start now?
Yes, sir.
Okay. Good morning, students. Today so far we have discussed about the emissions. What are the emissions to be coming from the automobiles, particularly in IC engines, spark ignition engine and combustion ignition, and how to control this. That is a very important fact. In olden days, that means in 90s and till Euro 4 norms, you have a lot of methods will be applied to control the uh, norms of the pollution content in the exhaust gases and evaporative emissions. And now I'm going to give you for a few basic things what you have before Euro 4 norms. You have some arrangement has made for the controlling of the emissions. Three basic methods used to control the engine emissions. And one is the engineering of combustion process. Basically, I talked about supercharging, turbocharging, and the improvement of the ECU unit, and how to control the PLA mixture. Particularly, what we have studied so far is whenever you are having the uh, purified air is required for getting up the combustion, and we are going to use supercharger for additional purpose, and turbocharger also will be using. And these two are the general methods to control the, and because we are enhancing the combustion process to improve the quality of the combustion. That is very important for the supercharging. And then whatever exhaust gases will be having, that exhaust gases will be reusing it, and through using a turbocharger, and we are going to enhance the heat and air heat, and we are sending it back to the engine. And there is a lot of methods will be coming. Now we have to how to control the exhaust emissions also. We have one method is engineering of combustion process, advances in fuel injectors. Fuel injector automation should be advanced, and oxygen sensors will be using how much oxygen percentage is going inside through the fuel injectors or the through air, and onboard computers will be arranging This will be monitored with the computer and all. I told already, whenever you are traveling in a city or the crowded places, lot of pollution will be there. Whenever you are traveling in the outside the environment and forest area particularly, your sound will be sensing it very smooth, and engine noise will be very smooth, and engine movement also very smooth, and very good combustion will be happening. You are going to forest also, you also will be relaxed by having a smooth and a good percentage of oxygen of air. If you have a good percentage of oxygen of air, your breathing will be good and your health will be good. Because particularly in hospitals, whenever the patient is struggling for something, they are going to use the oxygen. Oxygen mask will be using, oxygen will be given to the patient to recover very fast. The similar way you have engines also will have a breathing, air breathing. For that we have a oxygen sensors. Onboard computers will be arranging the first method. And the next one is optimizing the choice of operating parameters. One is operating parameters also. I told, but initially if the vehicle is not starting, we have to go operate with uh, uh, choke arrangement. We are giving the choke for two-wheelers and four-wheelers. Once the choke is given, more air, more fuel will be going inside and combustion will be taking place. Because if once we go to the rich mixture, automatically the hydrocarbons and carbon monoxide percentage will be increasing it. And optimizing the choice of operating parameters to the NOx control measures that have been used in automobile engines are spark retard and the EGR. Spark retard and EGR, exhaust gas recirculation method will be using to control the NOx emissions also, and using of this EGR method. And of treatment of device in the exhaust system, one is a catalytic converter. And I made one project in BTech project in 1995. We made the catalytic converter in our IC engine lab. Whenever you are visiting the IC engine lab, you can see the catalytic converter. In that time itself, we have made the catalytic, two-way and three-way catalytic converters are available. And we are connected to that catalytic converter, and we have seen that how the emissions will be coming. Particularly, this catalytic converter will absorb the NOx and SOx content, those who are harmful, and carbon monoxide also it absorbs. So there is some chemical arrangements I will explain you. And this absorption, it absorbs the contents, and it stores it, and pure air will be coming out through the exhaust. Now, effect of air fuel ratio, we already seen it, and higher and lower according to this, and stoichiometric, rich mixture and lean mixture, and too much of oil is 14.7 to 1, and too much of air also will have causes the problem. And you can see this, if the air fuel ratio will be varies from lower to the higher, how the NOx and hydrocarbons and carbon monoxide and fuel economy also will be goes it. This we already discussed in the previous slides. And typical emission control devices are positive crankcase ventilation, PCV valves. Positive crankcase ventilation. This is particularly in two-wheelers. We have a lot of problems because in the crankcase we store the oil for lubricating of it, and this oil will be having sometimes, because in the two-stroke cycle the charge or mixture, homogeneous mixture will be entering into the crankcase and going to the through transport board to the for combustion purpose. But in diesel four-stroke engines, method will be different. The fuel or air mixture, homogeneous mixture will be entered from the inlet valve and getting up the combustion. But that's why what happens, where crankcase ventilation is required, positive crankcase ventilation is required for having the valve operation, and air pump is also required, or the supercharger is required. Control supercharger also enhances the air pressure, particularly in diesel engines or petrol engines. Homogeneous mixture, it updates it, and high pressure air will be entering into it, getting up the combustion is very easy. Evaporative emissions canister will be there. Evaporative emissions also can be controlled through using, have a small mesh type of canister will be using. It absorbs the evaporative emissions, evaporative control from the sun rays or environmental conditions. That is, evaporative emissions also can be controlled through this. One thing is from the engine side, another side is called real tank. And the exhaust gas recirculation, whatever the exhaust is going out, that exhaust gas can be recirculated through this system. And once the easier will be there, whatever exhaust is coming out, that easier will be recirculated. And we have like a small boiler will be arranged. There's a easy exhaust gas recirculator will be like a small tube will be having inside the tubes, cold air will be passing it, and around these exhaust gases will be circulating of it. And once the temperature will be reduced and it will be cooled, and some content will be left over there, and less temperature air will be coming out to the atmosphere through this exhaust gas recirculation. Another one is the catalytic converter. This is one device we are attaching to the exhaust pipe, exhaust releasing pipe outlet, then it will be having some absorption contents will be there inside chemicals, and absorption content will absorb the particles NOx and SOx particles, and it releases outside, and you are going to get purified exhaust gases, particularly in diesel engines and petrol engines. This catalytic converter can be used. And efficiency of three-way catalytic converter. This is about rich mixture and lean mixture hydrocarbons. CO you are seeing, NOx also seeing. The window we will be seeing. What you have green line is a stoichiometric air fuel mixture. Always stoichiometric air fuel mixture will be sent to the engine. But initially we have a rich mixture, and later on, whenever it's going very higher speeds and very clean environment, good oxygen percentages and air percentage will be there. In the too much air will be called as a lean combustion, and too much fuel will be called as a rich combustion. Then we have correct mixture will be having that is called stoichiometric air fuel mixture. If you send it the clear stoichiometric air fuel mixture, and automatically this combustion and exhaust pollution rate will be less. And now we are going to talk about, I have seen the supercharger and turbocharger and these things. Now I will talk about the catalytic converter is a device that uses a catalyst to convert three harmful compounds in car exhaust into harmless compounds. The three harmful compounds are, you know that last three classes I am discussing about, always I am talking about hydrocarbons, carbon monoxide, nitrogen. SOx is a very small, and particulate matter is for diesel engines, and how to control that also we'll discuss it. But before that, catalytic converter is a device that uses a catalyst. Catalyst will be using to convert three harmful compounds in car exhaust into harmless compounds. The three harmful compounds are hydrocarbons and carbon monoxide and nitrogen. And these three hydrocarbons and carbon monoxide, nitrogen, how it will absorb it through chemicals. Which chemical will absorb it, and keeping the chemicals inside, and it will be exposing these exhaust gases to these chemicals, and chemicals will absorb the hydrocarbons and carbon monoxide and nitrogen gases and release it in the air in the form of unburned gasoline, and the hydrocarbons will be evolved. You know that unbound hydrocarbons will be having, and few carbon deposits will be there in the liners, and few hydrocarbons are coming out from the exhaust. And carbon monoxide, this is also very dangerous and formed by the combustion of gasoline. These three will be getting it from the combustion only. Nitrogen oxide created when the heat in the engines forces nitrogen in the air to combine with oxygen. This is also having created when the heat in the engine forces nitrogen in the air to combine with the oxygen. And now I'm going to talk about the catalytic converter. This catalytic converter design like a small tube, this is the shape of the catalytic converter. This will be having a two narrow connectors will be there. One side is connected to the exhaust gas. This is a canister where you have so we call it as silencer. You maybe heard about the silencers will be there for two-wheelers and four-wheelers also. Because after combustion, a lot of exhaust gases will be coming with the sound, noise, and the pollution. This exhaust gas will be having silencer will kills the sound, and some of the things will be killed and coming out. Still, we have a sound will be coming through the exhaust, but still we have a silencer will be fitted to. You may be observed in two-wheelers and four. Whenever the silencer is removed, you get a lot of unobserved noise, and it is irritating to the persons also. When it is silencer is there, and it automatically silencer will kills the sound and gives the good sound. Because these silencers also we have a different types of designs, different sides of things. Somebody will likes it, Yamaha particularly. Yamaha sound is a very good sound, and Bullet sound is very good, and their silencers and their designing criteria of the engines are different. And once the Yamaha is not compromised with the two-stroke engines, because Yamaha is very crazy bike where you have the many people will likes it sound of the Yamaha bike and Bullet also. And because of the pollution, other things, government has not given the permission. Immediately they switch over to the four-stroke engine. Once the four-stroke engine mode has changed in the engine, then automatically the Yamaha's bike's craze has lost, because immediately Bullet also has a lot of improvements has come out of this, and now new Bullets are seeing it, new Yamaha bikes are seeing it, but crazy is a little bit less, but Bullet is having a lot of improvements and good improvements. Many people are buying it, and that will be having a sound and all. And then this even Bullet designs also, they are given different types of sensors Silencers will be giving a different noise and different exhaust will be coming out for different modes. And particularly this catalytic converter will design, we have a one shaped wall, then two narrow things. One narrow will be connected to the silencer, another narrow will be connected to the exhaust pipe, and in between of the exhaust releasing and before after the silencer, this the catalytic converter will be fitted. And in catalytic converter, the catalyst in the form of platinum and palladium. Platinum and palladium are the two chemicals will be adding to this catalytic converter. Is coated onto a ceramic honeycomb structure will be there, and or ceramic beads that are housed in a muffler like a package attached to the exhaust pipe. And before after silencer, we are going to attach the catalytic converter. Catalytic converter will have a two-way and four-way of the pipes, and whatever the exhaust is coming out, the exhaust will be having will be exposing the outside, and the chemicals will be having platinum and palladium will be coated in a honeycomb structure of the catalytic converter. And this catalytic converter will have a two-way and three-way type of modes will be there. Anyhow, we'll discuss it. And in this actually you have the in these two layers type of thing. When the exhaust gas will be coming out, it will be exposing to the platinum and palladium, and it attracts the HC and CO and NOx little bit, not a good percentage. At least 50% of this controlling will be there by using of this catalytic converter. But one problem is there, catalytic converter, whenever you are going for a servicing, you have to clean the catalytic converter and you have to use for the new coatings or new things. You have to check up this thickness of the palladium and platinum things where it will be exposing a heat. And the catalyst helps to convert the carbon monoxide into carbon dioxide, and it converts the hydrocarbons into the carbon dioxide and water. And this, if you see this catalytic converter, you will get because of the cooling and all, just will also having small water vapors through hydrocarbons. That will be like a water vapors will be coming out from the catalytic converter also. It also converts the nitrogen oxide back into the nitrogen and oxygen. This is one. The one thing is carbon monoxide will be converted into carbon dioxide, and hydrocarbons will be converted into again the carbon dioxide. And you have nitrogen. Particularly, if you see this, nitrogen will be as a nitrogen and oxygen. Then it's a little bit. If you compare with the nitrogen oxide, will be reacting with the atmosphere and getting a lot of problems. But because of this, we are having the nitrogen and oxygen to be coming out, and carbon dioxide is coming out. Then you may be getting it little bit pollution levels will be decreasing. Carbon dioxide is helpful to the plants to grow more, and it absorbs the carbon dioxide and release the oxygen. You know it, and particularly for our purpose, carbon dioxide also will be dangerous for us for inhaling it. But comparing with the carbon monoxide and hydrocarbons and NOx emissions, and this will be a little bit easier. And this is the basic design of a catalytic converter. And this is the called ceramic honeycomb catalyst will be there here. This is the catalyst where you are keeping it. And this is inlet where you are going to connect to the silencer. Silencer outlet we are going to connect here. And coatings of alumina and PT, PD and RH will be there for below this thing. And substrate where our catalyst fat shell will be housing. This is called catalytic house shell will be having, and uh, intumescent mat will be there here to observe the once it is exposing here, and again we have one more thing, and here we have insulation will be there around catalytic or heating will be there because exhaust gases will have high temperatures. The high temperature may dangerous. It may be having from initial to 400 to 1000 or 2000 also sometimes have exhaust gases will be very high temperatures will be coming from the combustion only. That's why what happens, you have a insulation is required for this thing, and you have insulation cover also will be there, and it is having an outlet. And this is called the shield where you have a, this is the shape of the structure of the catalytic converter. You may be having this catalytic converter, maybe having this type, maybe having a star type, you may be having a different types of catalytic converters are available. This is the one design where you have having the drum shape like a boiler, and it will be having the absorption content will be in the front. Whether it is exposing to the absorption content, automatically the exhaust gases will be absorption will be taking place here. After absorption, it goes to the mesh again. but these particles will be collected here. This is housing where we have, and again we have the shield will be there, and it will be going out through this outlet. And insulation will be there around the catalytic converter to the chamber, where you are going to have the temperature may not be exposing outside for heat and other things. This is the one design, one type of design, and catalytic converter may be having different types of shapes also. And particularly, it will be having one bowl shape, and other things, two ends will be connected to the these things. And this is called converter fuel flow, or 260 cubic in bed volume. And this is about the another shape of the catalytic converter, where you have the shape, you have insulation, outer wrap will be there. Then you have a converter will be there. You have the weight of 260.2 lbs in kgs we are going to have, and 18.7 kgs, and 2.5 diameter of the hole will be there. This is called from the silencer we are going to convert here, and this is called outlet, where you have 12.3 adjust diameter will be there, and the designing of this is 3.5 height will be there, and the size will be having 18.7 centimeters, or the height is given, and inlet gas will be entering here, and it going to the catalytic converter, and the compounds will be there in the particles. Different types of shapes you can arrange it, and different modes we are going to have. This is the outlet region, where inlet and outlet regions will be having the almost same size, but outlet will have more size, inlet will have less size, because and you can see it here, real catalytic converter, how it looks. This is called it will be connected to the silencer, and it will be connected to the outlet mode. And you have a seal will be there, metal mesh will be there, shell arrangement will be there. This only thing is, whatever the platinum and palladium will be exposing to the atmosphere, and in the catalytic converter, and absorption will be taking place. Once it is absorbed, it automatically only 50% can have the cleaning of the exhaust air from this method, due to 60%. That is more than that. It will having the method of cleaning of the hydrocarbon, carbon monoxide, and we have the NOx emissions. And the active catalyst material is impregnated, granted. On the surface of catalytic substrates, and supports the function. Basically, it substrate and support the function of the catalyst substrate is to provide maximum possible contact of catalyst with reactants. Following are the main requirements of the catalyst substrate: high surface area per unit volume to keep a small size of the converter, because size of the converter also very important in the design point of view, how it is connected and how it is. That's why what happens, sometimes you may be having two catalytic converter in high-end vehicles. Those having a cubic capacity of 2000 or more than 2500, they will keep two catalytic converters and, connected to the exhaust silencer, and they will maybe arranging of it. Should be compatible with the coatings of a suitable material, wash coat, to provide high surface area and a right size of the pores on its surface for a good dispersion and high activity of the catalyst, and low thermal capacity and efficient heat transfer properties. Heat transfer means absorption capacity will be the more. Whenever the high temperature gases will be coming out, that gases absorption rate should be also be increasing. That we call it as heat transfer rate. And for quick heat up to working of the temperatures, it is quickly taking it, absorbing it. For this thing is called ability to withstand the high operating temperatures up to around 1000 degrees centigrade. Out exhaust gases will be coming out. The minimum I told actually depends upon the engine capacity, engine speed. We are going to have 1000 degrees temperature. The high resistance to thermal shocks that could be caused by sudden heat release when high and hydrocarbons from the engine misfires get oxidized in the converter. You may be seeing it sometimes if you are going in a two-wheelers or three-wheeler. If the engine is misfired, you are going to get a sparks also through the flame arrestor. What we have here, silencer is not good acting it. Sometimes the sparks will be coming out from the combustion to the exhaust also. That will be flame arresters to be arranged in the silencer to absorb the flames inside the silencer itself. That's why when if you touch it, the silencer, it's a very hot. You'll be having a similar way. Catalytic converter also. That's why we have seen the two layers of the insulation is provided inside the catalytic converter. Low pressure drop will be required. Ability to withstand the mechanical shock, vibrations at the operating temperatures under road conditions. Ability to withstand the mechanical shocks and vibrations at the operating temperatures under road conditions. Condition for a long life and durability also required for the catalytic converter. And particularly the following types of catalytic supports are used. Pellets will be using, monolithic supports will be using, and ceramic monolithics will be using, metal monolithics will be using. These are different types of things we'll be using in chemical compounds to be coated in the layers in the catalytic converter. It absorbs the hydrocarbons, carbon monoxide, and we have the NOx emissions. And this is about the alumina wash coat, how we are arranging on the surface of the catalytic converter. And ceramic monolithic matrix will be arranged here in the front, where we are going to have, this is called, here we are going to arrange monolithic, the shapes will be having, depends upon the catalytic converter shape, and the mesh will be arranged this model or this model. And converter shell will be using like this, ceramic monolithic will be using. Exhaust gas flow will be out, and this will be in. And if you see the COHC diffuse into porous matrix, we are going to have, this is the monolithic substrate, aluminum wash coat will be there, and it will be exposing to the COHC and to this thing, coatings, aluminum coating. This will help to absorb the things. CO2 H2 dissolves and enters into exhaust stream, and it will be going out to the exhaust stream. And PT catalyst sites and porous will be having 2200 degrees of ambience will be there. For this, materials will be using inside the catalytic converter to absorb the exhaust content of your exhaust gases. This is about the two-way catalytic converter and all. And after the seeing of the two-way catalytic converter, they are having some improvements as made as a three-way catalytic converter. This also will have gives the good thing about this thing. A catalyst forces to a reaction at a temperature lower than the normally occurs. A catalyst forces a reaction at a temperature lower than normally occurs. As the exhaust gases flow through the catalyst, the NO reacts with the CO, HC, and H2 via reduction reaction on the catalyst surface. That is called NO plus CO gives half N2 plus CO2, and NO plus H2 will use the half N2 plus H2O. I told already water drops also will be coming through this absorption and catalytic converter, and this exhaust will also will cools it, and automatically it uh, uh, for converted into that high pressure is into a steam form, and we have water drops form. And other remaining CO and HC are removed through this oxidation reaction forming CO2 and H2O products. Air added to the exhaust after exhaust valve also. And once the air is added, and again the cooling will be taking place. And three-way catalyst will function correctly only in the exhaust gas composition correspond to nearly plus or minus 1% of stoichiometric combustion. A three-way catalyst will function correctly only in the exhaust gas combustion composition corresponds to nearly plus or minus 1% of stoichiometric combustion. You may be observing it now. We have catalytic. Now these are the about the previous methods. Now presently Euro 4 norms will taking care of everything because according to the load and according to the speed, we are sending a stoichiometric air fuel mixture to the combustion chamber. The combustion is going to improve it, and now you can see the engine's efficiency also is increasing. Thermal efficiency and mechanical efficiency also is increasing. But with higher speeds and higher loads, also vehicles will be performing very well in this thing. And you are going to have very good improvement in the engine point of view by using of electronics, ECU method and all. And Euro 4 norms also will be reducing drastically to the pollution norms. And we are talking about a three-way catalyst will function correctly only in the exhaust gas composition compounds to nearly plus or minus 1% of stoichiometric combustion. The exhaust is too lean, NO is not destroyed. The exhaust is because higher air percentage and lower is fuel, we have a lean bulk combustion. There we are going to have the NO is not destroyed. And if the exhaust is too rich, means rich mixture means more fuel and less air, that also will causes the and creates more of CO and C are not destroyed. And this also will have in three-way catalytic converter have a very good purification, but stoichiometric percentage should be improved to getting of a good combustion. A closed loop control system, an oxygen sensor, when the exhaust is used to air fuel ratio and used to adjust the air fuel injector so that the air fuel ratio is near to the stoichiometric fuel mixture in the diesel engines. And the oxides of basic metals such as the copper, chromium, nickel, cobalt, etc. have been studied. Because using in the catalytic converter also different types of things also will be using. Copper will be using to observe the oxides of nitrogen, and chromium will be using, nickel will be using, cobalt will be using, and this will be nitrogen oxides. Particularly through NOx only we are going to get the oxides. The oxides also will be absorbed by using of copper, chromium, nickel, cobalt, etc. The base metal oxides are effective only at higher temperatures. The base metal will be having some metals will have absorbs very easily to higher temperatures. In addition, that sinter and deactivate with the subject to the high exhaust gas temperature experienced at high engine loads. This is also a very important point. In addition, the slitter and deactive with subjected to high exhaust gas temperature experienced at high high engine loads. Their conversion efficiency is severely reduced by sulfur oxide, reduced by sulfur in PL. The noble metals, particularly platinum PT, palladium PD, and rubidium RH, are found to meet the above mentioned performance requirements. In practice, only the noble metals are used, though these are expensive. Basically, in catalytic converter designing and other thing, one aspect, and it will be having additional cost to your vehicle for the fitting to the catalytic converter also. That's also one problem because the material cost, chemical metals, the coatings and all will be more expensive. If you add to the catalytic converter, the rate of the vehicle also will increase it. Mixtures of noble metals are used to provide the higher reactivity and selectivity of a conversion. Mixtures of noble metals are like a platinum, palladium, and rubidium. Metals are used to provide higher reactivity and sensitivity of conversion, following as a typical formulation. And platinum, palladium in 2:1 ratio for oxidation catalyst, and uh, platinum, palladium, when rhodium in ratios of 5:1 or 10:1 for the simultaneous oxidation and reduction, such as in three-way catalyst. Palladium has higher specific activity than the platinum for oxidation, CO, olefins, and methane for the oxidation of paraffin hydrocarbons. And platinum is more active than the palladium. Platinum has a high thermal resistance and deactivation. Rubidium is used as NOx reduction, and the catalyst when simultaneous conversion of COHC and NO is desired as in the three-way catalytic converters. The amount of noble metal used typically varies from about 0.8 to 1.8 gram per liter and 25 to 50 grams per feet per 3 to catalyst. You know about the platinum is very costly, and wearing a platinum ring itself very costly. And these are the very costly effects. Very high-end vehicles will be using the three-way catalytic converters. Very costly vehicles like a Skoda, like a Audi, and other people, those are imported cars, they're all having the catalytic converters and all. And in our India also, we are using for high-end vehicles, they will prefer to the three-way catalytic converter. But normal vehicle, catalytic converter will be using for getting of the purified clean air of exhaust. And next, we will discuss about the properties of the catalyst. The active catalyst material is required to possess the following main characteristics: and high specific reaction activity for pollutants, high specific reaction activity for pollutants, high resistance to thermal degradation, and good cold start performance. And suppose you are connecting to the catalytic converter to the silencer also will have, sometimes you may get a cold start. But initially, once the combustion will start, only it will be activates. Like also you have some designs, will be small modifications in the catalytic converter also there. Low deactivation, simple observation, you close the silencer mouth in exhaust, and if you want to start your bike, it will not start. Because once you release it only, you are going to start the bike. That's why what happens, once you are connecting to the silencer to the another additional part, it may cause us to the cold start also. And good starting performance is also required, and the low deactivation causes by fuel contaminates and sulfur or other desirable requirements are low. And this is about the cost also more effective for using operation. And this is all about the catalytic converter and all. Shall we go to the exhaust gas recirculation or will we wait for tomorrow's class? Hello friends. Hello.
Yes, sir.
Yes.
You're audible, sir.
Audible? Huh? Okay, shall we close it? Just gas recirculation will be there. This is a very high topic. Okay. Huh? This will go to the next stage. Okay.
Okay, sir.
Start preparing of your object type of questions from the syllabus what I told you. Okay. Up to the combustion ignition. Any questions?
No,
Hello,
sir.
friends? No questions?
No, sir.
Now I am fast or slow? Is it okay for you?
Sir, somewhat you are fast going, sir.
Fast going only because I have a vast experience, 30 years of experience in IC engines.
But we don't have, no, sir.
Okay. Anyhow, I am controlling myself. When I will involve in the class, I cannot control the things. Okay, anyhow, I will slowly I am improving it. Okay, and I got the 3 years gap also, and I have gone to the state government for as a member secretary for science and technology and came out. Okay, I have 3 years lagging behind of me of this. Okay, anyhow, okay, all the best. Okay.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Okay.